Hello guys, I hope everyone is fine. In today's video, we will be discussing the concept of dynamic programming. So what is dynamic programming and what are the advantages of dynamic programming? That's what we have to discuss. But firstly, let's understand what is the use of dynamic programming. Firstly, it is used to provide optimization solutions. Optimized solution or optimization, it's used to solve optimization problem. So what is optimization problem? Let's say if we are using Google Maps and there is one path that we see and path 2 we see, and let's say there is path 3. A person has to follow a particular path to reach to a particular destination. So one of the path that person has to choose. The point is, if what is greedy technique? Greedy technique will always find the shortest path. But in dynamic programming, we have to properly analyze where we can reach, which path we can actually opt to reach our destination without any kind of pauses. So it means that path 1 can be a shortest path, 2 or 3 can be shortest path, but the important point is which is used to solve an optimization problem. The optimization problem that you should reach without any kind of rush, irrespective of it is a shortest path or not. So there, these problems are solved. Now, the biggest advantage of dynamic programming, or there are two important points regarding dynamic programming, is that dynamic programming always provides us optimal sub sub substructure. You know what is optimal substructure? Optimal substructure is that it is something that a problem is, we have a particular problem. It can be divided into subproblem 1, subproblem 2, and we are solving these subproblems to find the solution of entire problem. So this is optimal substructure. I'll let you know because there is a difference between dynamic programming and divide and conquer. And secondly, we have overlapping subproblems. Overlapping subproblems is that what is overlapping subproblems? We need to divide the problem into subproblems, and the solution of subproblem 1, let's say if the similar kind of solution is provided for subproblem 2, so we can overlap them. Means we can use the solutions of subproblems and overlap with other subproblems. Overlap with other subproblems. I'm just giving a very simple example. Let's take an example of Fibonacci series. So, guys, if I choose Fibonacci series with 0, 1, 1, 2, 3, 5, 8. If Fibonacci of 0 is 0, Fibonacci of 1 is 1, Fibonacci of 2 is 0 plus 1, right? Then Fibonacci of 2 is obviously 2, but it is addition of 1 plus 1. Then the next answer is 1 plus 2 is 3. So if I talk about Fibonacci series of 5, if I want to calculate Fibonacci 5, which is this one, let's say, so how we are going to calculate? So we will calculate it as Fibonacci of 4 plus Fibonacci of 3, right? That's what we have to calculate. If I have to calculate Fibonacci of 5, so 5 will be calculated when 2 plus 3 becomes 5, right? So what is Fibonacci of 4? So it means 5 will be calculated if previous to it, which is Fibonacci of 4, is added to Fibonacci of 3, which is the answer is 2. So it means similarly, I can also write Fibonacci of 3 plus Fibonacci of 2. Even Fibonacci of 3, I can calculate it as Fibonacci of 2 plus Fibonacci of 1. Now, the point over here is what is overlapping? The overlapping is that we are calculating Fibonacci 3 over here. But what if we calculate the answer over here? This answer. This answer can be solved in this particular answer also. So Fibonacci of 2 plus Fibonacci of 1. So this answer Fibonacci of 2 and Fibonacci of 1, if they merge together, we get this answer as Fibonacci 3. Why I have to calculate this? We all know the formula of Fibonacci 3 would be Fibonacci of 2 plus Fibonacci of 1, and which we have already calculated. And why we are calculating? We are rather going to overlap them. You getting my point or not? So the important point over here is that very important point, very important point in dynamic programming is that we can always overlap solutions. And what we can do is that dynamic programming is always solvable in tables. Is always solvable in tables. We can use pre-existing data. We can use pre-existing data and we can calculate next solutions by taking pre-existing data as a reference. So this is very important. This is known as dynamic programming. Now, the best example of dynamic programming I have given you as Fibonacci series. We are using the answer of Fibonacci 3 and putting it in there. Why we need to waste time to calculate the same thing again and again? Like, just see over here, we have calculated Fibonacci 3 over here, and why we want it to be calculated again. So we won't waste time. We'll rather use this answer over here. Same applies with dynamic programming. We can always use pre-existing data. If the answer is calculated, we'll just use that to our own reference. Fine. Hopefully this problem is clear.